ఛానల్. సో ఈరోజు సిమిలర్ ట్రయాంగిల్స్లో ఒక థీరం ఉంది. లెట్ మీ ఎక్స్ప్లెయిన్ ద థీరం. నేమ్ ఆఫ్ ద థీరం ఈజ్ basic proportionality theorem. So here we can call this theorem as by using another name, that is Thales theorem. So ఈ Thales theorem యొక్క proof ఎలా ఉంటుంది? Before going to know the proof of that basic proportionality theorem, let me explain about some concepts. So here listen to me. This is a triangle. The name of this triangle is nothing but acute angled triangle. So here, if you take that name of the triangle as ABC, from this vertex, if you consider a perpendicular AD, that perpendicular which you are taking in this triangle from vertex A to the side BC, this AD is called height. So here, this AD height you are taking for which side? That means for which BC side. So here BC is nothing but base of the triangle, and here height is nothing but AD. Height is nothing but AD. Next, one more thing. This height we can consider from this vertex also. If you consider the height from this vertex, now we need to take that perpendicular as in this way, and that perpendicular I am taking as BE. When you are considering height of this triangle as BE, then base we need to consider as AC. And finally from this vertex also you can consider one more perpendicular, and whenever you are considering the perpendicular from this vertex C, then this CF we need to take as height or altitude of this triangle, and in this case you need to consider AB as its base. That's all. So this is taking perpendiculars in a acute angled triangle. For example, if you have a right angle triangle, then what about the base and height? Listen to me. This triangle of name I am taking as PQR, and here PQ and QR both are perpendicular to each other. Now we can take that PQ and QR as the perpendicular sides of this right angle triangle. So here, when you are having a right angle triangle, and which sides you are taking as perpendicular sides, in this case one perpendicular side if you consider as height of the triangle, the another perpendicular side you need to take as base. For example, PQ if you consider as height, then QR you need to consider as its base, and RQ if you take as perpendicular, that means height, then PQ you can take as base. So that's why that means the product of these two perpendicular sides, half of the product of these two perpendicular sides is nothing but the area of the right angle triangle, you can say. So here one more thing is there. From this vertex Q you can consider one perpendicular, and that perpendicular I am taking as a QS. When you take a QS as perpendicular and a QS as its height of this right angle triangle, then you need to consider PR as its base. In such case, in such way we can take the perpendiculars or altitudes in the triangle. Now listen to me. By applying the formula, that means by taking PQ as the height, QR as base, the area which you get, and PQ as QR as height and PQ as base, the area which you get, and by taking QS as height and PR as base, the area which you get, in three cases we get the same area. That one you need to keep in your minds. Next, one more triangle let me introduce. So this is a triangle. How can you call this triangle? Means this is an obtuse angled triangle. Obtuse angled triangle. Where you are having obtuse angle means here we are having an obtuse angled triangle. Obtuse angle means less than 90 degrees. If one angle greater than 90 degrees, if one angle is there in the triangle, that is called obtuse angle triangle. Now listen to me. So this is the obtuse angular triangle. Here also from any vertex you can consider the altitude or height of the triangle. Now I am considering the altitude or height from this vertex. This is the perpendicular. So the height or perpendicular from vertex A, if you consider, that should be need to take for this side BC. But BC is starting from this point only. That's why we can extend this side up to meet this perpendicular. Now this is height, and just this part we need to consider as the base of the obtuse angle triangle. That's all. Next, one more concept I would like to say, because of these concepts are useful in this proof of basic proportionality theorem. That's why I am saying this concept. Here I am taking two parallel lines. Yes. Now listen to me. These are the two parallel lines. Between these two parallel lines, we are having two triangles. Observe the two triangles. This is one triangle. This is one triangle. And this is also one more triangle. This is also one more triangle. So, A, B, C, D. The name of this triangle is triangle ABC, and the name of this triangle is triangle ABD. If you observe these two triangles, they are located between two parallel lines or sides, and they are having a common base or common side. Whenever two triangles have been taken by you between two parallel lines and having a common side for them, that two triangles of areas are same. That two triangles of areas are same. This is one property. That means area of triangle ABC is equal to area of triangle AB, like in that way we can take. Why you are taking that the two areas of triangles are equal means these two triangles are formed between two parallel sides with a common side. Such triangles which are formed, their areas are nothing but equal. That's all. Okay. These concepts we need to keep in our minds. Now listen to me. Here, the first theorem in this chapter is basic proportionality theorem. The another name of that basic proportionality theorem is Thales theorem. What is the concept of that basic proportionality theorem? That means in a triangle, if you take a line parallel to any one of the three sides, that can divide the remaining two sides in the same ratio. This is the statement of the basic proportionality theorem. Let me explain one more time that statement. In a triangle, if a line is taken parallel to any one of the three sides of the triangle, that can bisect remaining two sides in the same ratio. Remaining two sides in the same ratio. One more time, the statement. In a triangle, if a line is taken parallel to any one of the three sides of a triangle, that can bisect the remaining two sides in the same ratio. That's all. Yes. Now listen to me. Here I am taking a triangle A, B, C. Here we are having three sides. AB is a side, BC is a side, and AC is also one side. Three sides it has. Here we need to take one line as parallel to any one of the three sides. That means in this triangle, for any one of the three sides, we need to take that line. We need to take a line as parallel to any one of the three sides. Now listen to me. This L line L, I am taking parallel to the side BC in triangle ABC. This is you have been given. But whenever you have been taken one line parallel to any one of the three sides of the triangle, that line can bisect the remaining two sides. That means that L bisects remaining two sides. That means AB and AC have been bisected by this line L. That's all. Now listen to me. This L means AB at a distinct point. That point you can take with name E, and this one also D I am taking, and this one is E. So here in this triangle ABC, L is a line parallel to side BC. Then that L bisects the remaining two sides AB and AC. That means AD by DB is equal to AE by EC. That one we need to prove. Okay. So first of all, statement we need to write. Statement. What is the statement? If a line is parallel to any one of the three sides of a triangle, then it bisects remaining two sides in the same ratio. This is the statement. Next, here first we need to write given. What is the given information? That prove. To prove the theorem, the clue which you have been given in the problem, that one we need to take as a part of given in the theorem. That's all. So what have been given means ABC triangle have been given, and a line L is parallel to BC. That one they have been given in the theorem. Yes, in triangle ABC, L is parallel to BC. This is we have been given in the statement. After that, required to prove. What we need to prove here? Whenever you have been taken one line parallel to one side of the triangle, that can divide the remaining two sides in the same ratio. That is you need to prove. So here we need to prove means L bisects AB and AC in the same ratio. That means AD by DB is equal to AE by EC. That one we need to prove. So to prove that one, we can construct some things. To prove that one, we can construct some things, make proof easy. What are they? Them you need to write in construction. Here the construction is, listen to me. From D, one perpendicular you need to take for this side AE. This is the perpendicular, that's all. In the same way, from E also one more perpendicular you need to create for this side AD. That's all. So this one I am taking as DF, and this one I am taking as EG. That's all. One more thing, you need to join D to C, and also you need to join B to E. These are the points in construction. So in construction, which steps you need to write means let. That means consider two altitudes or perpendiculars. Let two perpendiculars. What are they? DF and EG. DF and EG. DF you need to take for AE, for AE, and the EG you are taking for which side? AD. That's all. So this is first step in construction. What is it? Let two perpendiculars DF and EG for AE and AD, as well as join D to C and E to B. These two steps you need to write in construction. That's all. Now you can go for proof. Now listen to me. In this proof, how can we take? That means, listen to me. So here, this is a triangle. What is the name of the triangle? Triangle ADE. In this triangle ADE, if you want to find its area, and if you consider EG as height or altitude, you can take AD as base. Next, and to find this ADE triangle of area, if you consider DF as a perpendicular or height, then you can take AE as its base. But by taking this one as height and this one as base, and by taking this one as height and this one as base, by taking in these two cases, if you find the area of the triangle, you can get in both cases same area. That's all. So here, first I am taking this one as a height and this one as base to find the area of triangle ADE. Now, area of triangle ADE is equal to half into base is AD into height is GE. That's all. Okay. Next, after that, listen to me. Now I am taking area of this triangle. What is the triangle? Triangle DBE. This is an obtuse angled triangle. That's why from this vertex, if you consider the altitude for this obtuse angled triangle, it can meet by extending this BD side up to Z. That's why if you consider this EG as height of this obtuse angled triangle, this side you need to consider as its base. That's all. Now, area of triangle BDE is equal to half into base is nothing but BD into height is nothing but this one. What is it? GE or EG. That's all. Now, ratio of these two areas we need to find. That means area of triangle ADE by area of triangle BDE is equal to half into AD into GE by half into AD into BD into GE. Okay. Now, area of triangle ADE by area of triangle BDE is equal to half get cancelled, GE also get cancelled. Just you are getting AD by BD. This one you can take as equation 1. Next, after that, this same triangle of area again we are finding, but here we are taking DF as its altitude or height and AE as its base. Though if you want to find the area of this triangle of area in this case, in both cases you can get the same area. Okay, now area of triangle ADE is equal to, now half into base means this one you need to take as base AE into, now the height is nothing but DF. Next, after that, listen to me. Here one more obtuse angled triangle is formed there. The name of that obtuse angled triangle is nothing but triangle DCE. Now listen to me. Here we are having obtuse angle, and if you take for this obtuse angle the triangle BF as height, you need to consider this CE as its base. That's all. Okay. Now listen to me. Area of triangle. Area of triangle. What is the area of triangle? Now we are considering this obtuse angle triangle. What is it? DCE is equal to half into base is nothing but CE into height is nothing but DF. Height is nothing but DF. That's all. Now ratio of these two areas of two triangles we need to consider. That means area of triangle ADE by area of triangle BCE is equal to half into AE into DF by half into CE into DF. Now area of triangle ADE by area of triangle BCE is equal to half of get cancelled, DF get cancelled, just you get AE by CE. That's all. This one we can take as equation 2. Next. Here listen to me. In these two equations, the numerator part, if you observe, area of triangle ADE, both are same because of area of same triangle, but we are taking different bases and different heights. By taking in that way, we find out the area of the triangle in two types. So these two areas are same. Next, in these two equations, the denominator parts which you are having, their areas are also equal. Triangle BDE of area and triangle BCE of area equal. Why? Listen to me. Where the two triangles are located, just observe. Triangle, first one is triangle BDE. So that's one. Triangle BDE. This is the triangle. Next, one more triangle. Triangle CDE. So if you observe, these two obtuse angled triangles are formed between two parallel sides or lines with a common side. Such triangles of areas are same. It had been told by me in the previous theorem, in the previous of this class. That's all. So that's why these two triangles of areas are nothing but same, because of these two triangles are formed between two parallel lines with a common side. So their areas are equal. Okay. Now triangle or triangles BDE and CDE are between two parallel sides with a common side DE. Such triangles of areas are equal. Such triangles of areas are equal. Therefore, area of triangle BDE is equal to area of triangle CDE. Okay. Next, now from 1 and 2, how can you write? Area of triangle ADE by area of triangle BDE is equal to area of triangle ADE by area of triangle CDE or BCE, whatever it is. BC. Now, so this is left hand side part of equation 1. What is its right hand side part? AD by DB is equal to, this is left hand side part of equation 2. What is its right hand side part? AE by BC. Yes, it had been proved now. You can write simply, hence proved. But here some more information we are having. That means actually the theorem had been proved, present. So what is the theorem means? In a triangle, if a line had been taken parallel to any one of the three sides of a triangle, can divide the remaining two sides in the same ratio. This theorem had been proved now. But here, from this proof, some more information we can take. What is the some more information? Listen to me. AD by BD is equal to AE by EC. So here we can add 1 on both sides, or 2 on both sides, or 3 on both sides. So I am adding 1 on both sides. AD by BD plus 1 is equal to AE by EC plus 1. Now AD plus BD by BD is equal to AE plus EC by EC. AD plus BD. AD plus BD is nothing but AB, you know, AB. So AB by BD is equal to AE plus EC is nothing but AC. Okay, AC by EC. That's all. This is one information. The another information is actually what we have told that AD by BD is equal to AE by EC. Here I am taking reciprocals on both sides. If you take in that way, this equation will change as BD by AD is equal to EC by AE. Here also I am adding 1 on both sides. That means BD by AD plus 1, that is equal to EC by AE plus 1. BD plus AD by AD is equal to EC plus AE by AE. What is BD plus AD? BD plus AD is nothing but AB by AD. That is equal to, what is EC plus AE? EC plus AE is nothing but AC. AC by AE. This is another information has been proved from that proof. Listen to me. Actually we proved that AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. Second time we have been proved AB by BD, main side by some part, is equal to AC by main side by its respective part, EC. Okay. Next, in third, AB by AD, main side by first part, is equal to main side AC by its respective part. That's all. So in a triangle, if a line is parallel to any one of the three sides of the triangle, then that line can divide the remaining two sides in this way. That ways are AD by DB is equal to AE by EC, first way. AB by AD is equal to AC by AE, second way. AB by DB is equal to AC by EC, third way. That's all. Okay. Now I am going to stop the class now. If you have any doubts in this proof, you can send some messages to my WhatsApp number. I will try to clarify your doubts. Okay. Thank you. Bye.